All right, welcome back. Here is the second part, I guess, of this lesson where I'm going to go through and do the calculations. Let's take a look at finding the displacement first. For example, number one, I'm using the blue highlighted formula. So I'm going to put things into the blue formula. And again, just, in case you're not aware of this, at this point in my course in Physics 20, when I get students to put numbers in, I'm not concerned that they put the units in because their math background is not that solid yet. They haven't got a lot of practice in high school math. I think putting the units in at this point is confusing, and I would rather students be successful in getting the correct answer than not successful because something is just getting visually in their way. So I'm going to put in VF as 0, so I get 0 squared. I like to put brackets around anything I substitute, equals VI squared, which we know is 38.8 repeating. We're going to have to square that, plus 2 times the acceleration, which is negative 7.5, times the displacement. So what happens here? You do not have to write down what 38.8 repeating squared is. I mean, I'm going to do so, all right? That's enough. I mean, you get the idea. I have to square that. So I get 1512.345678. That's weird. I get 1512. I get 15. And then 12.345678. That's really weird. And then I have 2 times negative 7.5, which is negative 15d. And this is a very simple two-step linear equation to solve, but I want you to notice that if we didn't put that negative in with the 7.5, then when we solve this for d, we wouldn't get a positive displacement. And this is why those vector symbols need to be above the a and the d. I'm going to move the 15d to the other side. So finding d, I'm not even going to write that down. We're going to take this number and divide by 15 and get about 101 meters. So the answer to this question in terms of displacement is 101 meters. What about the time? Well, I said that we would use the formula that I have in yellow, so I'm going to take A equals VF minus VI over T, and we're going to solve for T. In this particular case, what I think I would like to do is take that formula and rearrange it first. I put the numbers in the previous question first. Here what I'm going to do is take A equals VF minus VI over T. I'm going to multiply both sides by T and get acceleration times time equals VF minus VI. Not sure why I wrote VF squared there. VF minus VI. This will be over 1, but if I divide both sides of that equation by A, I get the time is VF minus VI over the acceleration. Because this video is just giving you a quick solution, I'm not even going to do the substitution. I can go back up here, I can grab my calculator. Take VF, which is 0, minus VI, which is the 38.8888, which is 38.8 repeating, and I'm going to hit equals, and then I'm going to go divided by the acceleration, which is negative 7.5. So it all works out. We get about 5.2 seconds. I'm not worried about significant figures here. We're talking about how to use the equations properly to get correct answers. So 5.2 seconds. Those are the solutions to example 1. Example 2, where did we leave off? Let me just move forward here. We said that we could find the maximum height using VF squared equals VI squared plus 2AD. So I'm going to go ahead and do that. I'm putting the numbers into the blue highlighted equation. VF is 0, so 0 squared equals VI squared, which was 16, so that has to be squared, plus 2 times negative 9.81 times D. If I simplify this, you're going to get 0 equals, I think, 256 minus 19.62D. So 19.62D equals 256. Well, I can find D by taking 256 divided by 19.62. And while I'm doing this, I'm just going to confirm that my mental arithmetic was correct. 2 times 9.81. Yep. And then 16 squared. I don't know why my confidence is lacking. There it is. I just wanted to make sure. So 256 divided by 19.62. That negative 19.62D became positive when I moved it over. So what I get for the maximum height is about 13 meters. Now, when we find the time using the information in this question, don't forget that that time needs to be doubled to get the correct answer. We just finished doing this in the previous question. The time, when you rearrange what I will call equation 1, is VF minus VI over the acceleration. I don't think we need to re-explain how we got that formula. And once again, I'm not going to bother writing the numbers down. I need to take VF minus VI, which will give us negative 16, but just to demonstrate that to you, 0 minus 16 gives us negative 16. I need to divide by negative 9.81, and I'm getting about 1.63 seconds. So the time to the top is 1.63 seconds, but what I need to do is double that time to get the answer. So it'd be about 3.2 seconds. So the actual answer to the question is, I guess we would round to 3.3 seconds. We can say 3.3 seconds in the air. Total. Moving on to example 3, and I'm not going to go through the reasoning here again, but what we said was that you couldn't use the D equals VIT plus 1/2 AT squared formula to find the time. What you had to do instead is find VF first. We used the VF squared formula equals VI squared plus 2AD to find the velocity. We end up taking the square root of 786.7, but then saying the velocity at the end of the trip will be negative, and that's on us. When we take our calculator, and this is something I didn't really stress in the previous video, but when I take my calculator and take 786.7, and I take the square root, the onus is on me. I mean, I explained this, but I didn't maybe use this language. The onus is on me to say, you know what though? Is it positive or is it negative? And when the bowling ball is going to strike the ground, which is at the end of the total time, and we're after the total time, the velocity will be negative. So it's our responsibility to say, is it positive or negative? In this case, it's negative. So then what we said is that I need to now use this formula to find the time. Boy, this is deja vu all over again. This is the third time we're using this formula to find the time. The time will be equal to VF minus VI all over the acceleration. So that's going to be negative 28.04 meters per second minus, what was it, 10? 10 meters per second over negative 9.81. And I hope you see, just focus your attention on what I've just written. I hope you see that if this negative is not there, and you had 28.04 minus 10 over negative 9.81, you get a different answer. In fact, it will be a negative time. So, you know, maybe if you do that, it's good that you would get a negative time, because then you'd say, I must have done something wrong. Anyway, the negative is there. So now we can answer the question. So I have to take the negative of this answer. This is VF that's on my calculator right now. I need to subtract 10 and then divide by negative 9.81. So the answer to this question is the bowling ball will be in the air for about 3.88 seconds. Again, I'm not worried about significant figures, but I am going to put this to 2 digits and say 3.9 seconds. That's the answer to the question. We take a look now at number 4. Again, I don't want to relive all of the instruction here, but I do want to go over some part of it. This is going to be an identical situation where you cannot find the time directly because you end up with what we call a quadratic equation. So instead you find VF first. Now what I told you is that you're going to find VF, say it can be positive or negative, and then recognize that in this case it literally can be positive. It will have a positive velocity at this green highlighted point, and it will have a negative velocity at this blue highlighted point, and each of those will correspond to different times. There will be a short period of time to get to the green dot and a long period of time to get to the blue dot. So what I'm going to do is erase this so that we can put the numbers in. Let's see, what we're going to have is VF squared. Well, we're after VF, right? Equals VI squared, so we'll have 45 squared plus 2 times A, which is negative 9.81, times D, which is positive 20. So it's just a matter of me putting this into my calculator. I want to point something out again to you, that if you didn't put that negative for 9.81, you're going to get a different answer. These vectors up here, I just don't get why they're not on your formula sheet. I've never understood this. Those need to be there. If they're not there, you don't get the right answer. So what am I going to get? Let me see. I need to take 45 squared. I mean, I put 45 in brackets, but I don't need to put it in brackets on my calculator. Plus 2 times negative 9.81 times 20. And what I get is 1632.6. I take the square root of that. And I get, for VF without regard to direction, 40.4. So VF is 40.4 meters per second. And you know, that's true because VF is just the speed. But VF velocity is plus or minus 40.4 meters per second. So what we are saying, I'm just going to move this diagram down so that you can see this a little better. What we are saying is that at the green dot, it's the best way to do this, I guess I'll do it this way, is that VF can be equal to positive 40.4 meters per second, or VF can be equal to negative 40.4 meters per second, and it's equal to positive 40.4 at the green dot, and it's equal to negative 40.4 meters per second at the blue dot. So now what we need to do, we want to find the time. The previous couple of examples, I believe, made use of this formula. So that's what you need to do. You need to do this for the green and for the red. So what would I get for the green? it would be the time is VF, which is 40.4, minus VI, which was 45, over negative 9.81. I'll calculate that in a second. What are we going to get for the time to the blue point in this little diagram? We're going to get negative 40.4 minus 45 over 9.81, negative 9.81. And now I'm going to calculate both of those. We'll start with this one because it's right there. Minus 45 gives me this number, divided by negative 9.81 gives me 0.46 seconds. So 0.46 seconds after the object is released, it will be at the 20-meter mark. I'm just going to drag this over here. On the other hand, it's also going to be at the 20-meter mark with a velocity of negative 40.4, so I subtract VI, which is 45. I divide by the acceleration due to gravity, which is negative 9.81, and I get 8.7 seconds. So there are two answers to this question. The question was, at what time is the object 20 meters above the ground? It's 20 meters above the ground at 0.47 seconds and at t equals 8.7 seconds. So those are the completed solutions to those four examples. Over the next couple of days, we're going to continue to get more practice using a variety of different questions. I hope that when you did these solutions on your own, this is directed towards my students, that you got the right answers. You got the same answers that I got. So I hope that helps. We'll see everybody next time.